So I think we have some good examples here for the classwork, for the notes on simplifying square roots and simplest radical form. Remember that a radical is that when we talk about radicals, we're talking about that square root symbol or cube root symbol or whatever if you have the little 3 in there. But the square root symbol is what we call the radical. So simplest radical form means that we leave that radical, that we don't take that out and we don't put that in the calculator. Like we don't do the square root of 2 and then write out that decimal form because it's not an accurate number. The reason it's not an accurate number is it doesn't repeat. It doesn't have a pattern to it. So that's a radical. Also remember that the word rational numbers, and I'm going to just, you don't have to write your name up here, but rational, when we talk about rational numbers, we're talking about fractions. And then irrational numbers are the ones like square root of 2 or square root of 3, pi. All of those are called irrational numbers because they can't be written as a fraction. So rational numbers can be written as fractions. Irrational numbers cannot be written as fractions. So we leave them in this radical form, or we use the term, the symbol pi. So those are irrational numbers. That's just, you know, a review from the notes. We talked about that a little bit, but I don't know if I did a very good job explaining it. So, all right, so let's get started. Our first section is solving equations, solving quadratic equations. And remember, the word quadratic, it just means that there is an x squared term, or an a squared, or a b squared, whatever we typically use x. So it means that there is an x squared term there. It's called a second degree, or a degree of 2, because there's that exponent of 2. So that's all that means, quadratic, and it makes a parabola, which we'll look at later. So to solve for x, of course, we have to get the x by itself, which means on this one this particular problem, we're going to divide by 2, and we're going to end up with x squared equals, what is that, 49. X squared equals 49. But then what we do is when we take the square root of both sides, what we do is we say, okay, we're going to take the square root of this and the square root of this. Well, the square root of 49 could be one of 2 numbers. It could be a positive 7 or it could be a negative 7. So then we take this x squared out from under the radical because the square root of x squared is x. And we set up our first equation, our first part of the equation, to be the positive square root of 49. And then the other side is the negative square root of 49, because we know that negative 7 times itself also equals positive 49. So we need to be sure we include this negative part as well. So on the positive side, x equals 7. And then on the other side, x equals negative 7. So from here on out, what we're going to do, instead of doing 2 different equations, we're going to just write this as x equals plus or minus 7, like that, which means both of these things. Okay, and it covers both of them that way. All right, so let's look at the next one. This one we have to subtract 75 from both sides. So let's do that, and negative 3x squared equals negative 75. Okay, then we're going to divide by negative 3. X squared equals, this is going to be a positive 25. So when I take the square root of both sides, I'm just going to put that in a different color because that's the next part of the equation. Take that out from underneath the radical, x equals, and the square root of 25 is plus or minus 5, positive or negative 5. So this is a way we can just do it all in one step and not have to separate them into positive and negative. All right, let's look at the next one. I'm going to subtract 4x squared from both sides so that I get the x on the left. I like for the x to be on the left side. Divide by negative 4. X squared equals, that's going to be 12, I think. No, 9. I'm not thinking. It's going to be 9, positive 9. Take the square root. X equals positive or, getting ahead of myself, positive or negative 3. Okay, let's look at this one down here. Let's see, want to make sure 567. 567 will divide by 7. I'm going to switch this around. It's just my personal preference. I like for the x to be on the left. Divide by 7. That goes 81 times. Take the square root. X equals positive or negative 9. All right, I want you to pause your video for a second, and I want you to try this. Oops, try this next one, and then come back and see if you got it right. All right, so you should have gotten x equals positive or negative 2. And we say plus or minus 2 here. We don't say positive or negative usually. But x equals plus or minus 2, divide by negative 15, and then take the square root of both sides. All right, I want to do the same thing for this one. You might need your calculator if you don't know what 242 divided by 2 is. But I want you to pause your video, try this one, and then come back. Okay, so you should have gotten plus or minus 11 on that one. When you divide, you get 121. And the square root of 121 is plus or minus 11. All right. So the next section, these are still quadratic equations, but the 2 is on the outside of a binomial. So the first thing we have to do in these types of equations is, you know, when we have this part, let me highlight this real quick. When you have this part isolated, in other words, there's not like a plus something or minus something here or over here, then you can go ahead and take the square root on both sides. So if we take the square root, I don't want my highlighter now. If we take the square root here and the square root here, what we get is x minus 3 equals the square root of 36. So I want you to leave that like that. This is going to make it a little bit easier to do this. So if x minus 3 equals positive or negative 6, okay, this is when you can do it one of two ways. It's probably going to be easier to split this up into two different equations. The first equation would have the positive 6 in it, and the second equation would have the negative 6 in it. So let's do that. I think that might be the easiest thing to do. So the positive 6 we'll do in green. X minus, well, I thought I had green. X minus 3 equals positive 6. So x equals 9. And then the negative 6, x minus 3 equals negative 6. X equals, that's going to be negative 3. So this is two different answers that aren't just the positive and negative something. So these are the two different answers. And you know what? If you were to graph this, that would be kind of hard to do. You would have to put the minus 36 over here. So this is probably going to be the easiest way to solve these instead of graphing them. All right, so the next one, the whole binomial is raised to the second power. So let's take the square root of both sides and let's rewrite this. X plus 6 equals, and we can go ahead and take the square root of 625. That's going to be 25. So it's going to be plus or minus 25. So then again, I'm going to do the positive over here and the negative over here. So I'm going to set up two different equations. So my positive, I'm going to set up x plus 6 equals 25. And then the negative, x plus 6 equals negative 25. So let's finish solving this one. Subtract 6 on this side, and x equals 19. So this is one of my answers. This one's going to be subtract 6 over here. X would equal 31. So x, it's two different answers. Now it was two different answers up here too. It was positive and negative, positive 5, negative 5, positive 3, negative 3. Down here it just happens to be two different numbers that are the answers. So when you see something like that and you have a x squared, you're going to have two different answers for the solution. All right, I want you to, I'm going to rewrite this one just like I have been. X minus 7 squared equals 81. I want you to pause your video and try this one and then come back and see how you do. Okay, so you should have gotten 16 and negative 2 on that one. All right, let's look at these down here. Okay, so this one I'm going to leave. You do this one. I would switch the numbers around, but That's up to you. This one we're going to do together, this middle one. So this thing just really is irritating. Okay, so the first thing I need to do here, remember I said as long as this part right here is isolated, the part that's in parentheses, and the exponent is isolated as long as it's by itself on one side of the equation, you can go ahead and take the square root. Well, we can't do that here because we have this plus 49. So, I'm sorry, minus 49. So we're going to need to add 49 on both sides. Then we have x plus 10 quantity squared. When I say quantity squared, I mean the whole parentheses equals 49. Then we can take the square root. So x plus 10 would equal plus or minus 7. So then we do the two equations. And you know, you might can do this in your head. That's fine. That's great if you can. X plus 10 equals 7. The other side is x plus 10 equals negative 7. So this is going to be subtract 10, x equals negative 3. So that's one of my answers. And what we're really finding here is on this graph, we're finding the x-intercepts. So if we were to graph this right here, we would find that the x-intercepts would be at negative 3 and negative 17. Subtract 10 over here, negative 17. That does not look like a negative 17. Okay, there we go. Let's see if I can do that a little bit better. Okay, two answers, negative 3, negative 17. Okay, this one's very similar, and I'm gonna, let's see. Yeah, I'm going to rewrite this one. We can rewrite this as x minus 1 squared minus 64, because this is plus negative 64, equals 0. Now I need to add 64 on both sides to get this by itself, to get the squared part by itself. Okay, now I can take the square root. X minus 1 equals square root of 64 plus or minus 8. And then set up two equations. X minus 1 equals positive 8. And x minus 1 equals negative 8. So on my positive side, or on the green side, x equals 9. And the red one, x equals negative 7. My handwriting has always been so messy. My teacher used to make me stay in from recess to practice my handwriting. Okay. Let me see, make sure that I got the right things. Yep, those are right. Okay, let's move down to the next section. So you have one to do in this one by yourself. All right, so this is simplifying radical expressions. Some of them are going to have variables in them. Some of them will have numbers and variables. And then I think we're going to do some with just numbers as well. Okay, and remember, we are not going to use decimals in any of these. We're going to leave the radicals. So let's talk about this. So just want to remind you, anytime you have a variable and an exponent underneath the radical, to take it out from the radical, you just divide the exponent by 2. So divide the exponent. Let me write that a different way. I don't think that's going to make a lot of sense and just words. So you do the exponent divided by 2. Okay, and then if you have something left over, if it's an odd exponent, we'll talk about that in a minute. These are all even exponents. So all I actually have to do, and you know, we could talk about rewriting this as x squared times x squared times. That you don't really need to worry about. To take these out of the exponent, just divide the exponent by, out of the radical, I'm sorry, divide the exponent by 2. So this is going to be x to the 4th, y, z to the 6th. That's it. That's all you have to do. If this had been z to the 13th, then we would have a z left under that radical, but we'll do one of those when we get to it. Okay, so this next one, we're going to work with the number and the variables, the square root of 11. And on these, we're not worried about the positive or negative necessarily. I'm not worried about that. I just want to see that you can actually simplify these. So don't worry about saying, oh, it's plus or minus 11. I don't care about that on this part. So the square root of 121 is, so we can rewrite this as the square root of 121 times the square root of x squared times the square root of y to the 6th. Okay, square root of 121 is 11. Square root of x squared, divide that by 2 is x. Square root of y to the 6th is y to the 3rd. That's the answer. Okay, the problem comes in when you've got numbers that you can't take the square root of. Okay, because these are both square roots, because they're both, the radical is a square root, not like a square root and a cube root or whatever, we can multiply the 3 times the 12 and the x times the x. So I can rewrite this as the square root of 36x squared. So I can combine these by multiplying them. Now I know what the square root of 36 is, so then square root of 36 times the square root of x squared is 6x. And that's it. That's all you have to do with that one. But just remember, you can multiply those two numbers together if you need to simplify. Okay, so we have some fractions here. So this is the same thing as saying the square root of 64 over the square root of 81. The square root of 64 is 8. Again, we're not worried about the negative part of it right now. Square root of 81 is 9. Just understand that the square root of something is the positive or negative, but right now we're not worried about that. All right, this next one is a little bit different, but because this fraction bar means divide, we could rewrite this as the square root of 54 divided by the square root of 6. Well, 54 divided by 6 is 9, so that could also be rewritten as the square root of 9, which equals 3. Okay, and then this one over here, very similar. This is the square root of 2 divided by the square root of 32. Instead of rewriting it, what I can do is I can simplify 2 over 32. I can divide both of these by 2, and that's 1 over 16. So this also equals the square root of 1 over the square root of 16. Well, the square root of 1 is 1. The square root of 16 is 4. So I can rewrite that as 1/4. The problem comes in when you have a radical still left in the denominator. And so, and I think we'll get to one of those in a little bit. All right, so what you need to understand about roots is that if you have two numbers that have the same root like this, root 3, you can treat that blue part like it's a variable or something. This would pretty much be the same as if I wrote 2x plus 5x. You can add together what we call the coefficients and keep the same root, okay? So 2 root 3 plus 5 root 3 is the same as 7 root 3. So you can just add those two together. They're not really coefficients, but they're just the whole numbers. Okay, so likewise, 10 root 7 minus 2 root 7 is 8 root 7. Same thing over here. We have all the same roots. Now remember, there's a 1 right here. It's just like with a variable. 11 minus 2 is 9, plus 1 is 10 root 5. So you can add and subtract these as long as they have the same root. This one is 14 root 13 minus 1 root 13. That's 13 root 13. This one right here is 9 plus 9. That's 18 root 3. And the next one is, let's see, that's a 1 right there. So 1 plus 4, 5 minus 3, 2 root 2. All right, and I think that's it for that section. That was a whole page of practice. All right, let's move on. Okay, these are the ones where this is the one that I really want you to pay attention to and make sure that you understand. The next section below this, we're going to kind of speed through that. And then that'll be it. Okay, but this is like the most important section right here. So when you have a square root and you have a number that's not a perfect square, so let's just list our perfect squares over here. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 16. 25. 36. 49. 64. 81. 100. And then 11 times 11. And then 12 times 12. I always like to go up to at least 12 times 12. Okay, so what I'm looking for is I'm looking to rewrite 180 as the product of one of these perfect squares and something else. Okay, so 180, what will divide into 180? 18, that doesn't do me any good. Let's see, what else will divide into 180? What we might need to do is go over to our calculator and look for some factor pairs of 180. That might be a good idea. You might already know, but if you don't, you can always go over here and go to y equals, and then I just cleared it. Sorry, you have to clear it. And then 98. Oh, and I didn't do divided by x. I'm sorry, I didn't show y'all this whole thing. 98 divided by, and then your x is right here. And then hit second graph. And what it does is it shows you, I don't think I did this with y'all, but I might have. It shows you all the factor pairs, but you might have to go, what you're looking for is whole numbers. Well, there's the first one, 49 times 2, and 49 is a perfect square. So I'm looking for one of those numbers, one of those perfect square numbers that I wrote over in the margin. So one of these numbers over here in the left, so 49 is one of them. So I can rewrite 98, or the square root of 98, as the product of the square root of 49 times the square root of 2. And then I take the square root of 49 and just take the square root of it. That's 7. 7 root 2 would be my simplified answer. All right, I want you to pause, and I want you to try the next one, the square root of 325. See if you can figure that out, and then come back. Okay, so on this one, I found that 25 was a factor of 325, and I'm going to go through this one more time because I didn't go through this very clearly. So let me go back over here. You go to y equals, and then I'm going to clear this number. We're looking for 325. So you enter 325 divided by, and then your x button, which is up here beside the alpha button, divided by x, okay? And then we're going to go second, and then graph, okay? So then we have some numbers that multiplied times each other, like 40 times 8.125, 50 times 6.5. Those are not what we're looking for. We're looking for whole numbers, and we're looking for perfect squares. And you know what? I think I need to go back up, because it started for some reason at a 40 something. Here's 25 times 13. There's one of my perfect squares. So I'm looking for one of those perfect squares, whether it's 1, 4, well, not 1, 4, 9, 16, 25, or whatever. And I found that 25 times 13 was 325. So that was my perfect square that I took out of there. All right, let's look at this one right here. I recognize right off that 81 is a factor of this 810, and 81 is one of my perfect squares over here. So I'm going to rewrite this as a product of square root of 81 times square root of 10, because 81 times 10 would be 810. And square root of 81 is 9. Square root of 10 cannot be simplified. So the answer would be 9 root 10. I want you to try this one. And I want you to try this one. Use your calculator if you need to find a factor pair for that one. All right. Okay, so let me show you how this one works. So let's see, 243, I'm just going to tell you, is that's going to be, it's 81 times 3. So this is the square root of 81 times the square root of 3. So first thing I need to do is simplify these into simplest radical form. And then 2 root 75 would be 2 times the square root of 25 times the square root of 3. Okay, so we're going to rewrite this as 9 root 3 minus 2 times the square root of 25 is 2 times, that's 2 times 5. So that's 10 root 3. Well, now what we have is we have kind of what we would call like terms, because they both are root 3. So then we can combine these. 9 minus 10 is negative 1. So you can write it either negative 1 root 3 or just negative root 3. Okay, let's look at the next one. 98. Well, again, we just did that one up at the top. What did we find that one was? We said 98 is 7 root 2. So we can just rewrite it. 7 root 2 plus 32 is, let's kind of simplify this one up here so we can write it down here. 32 is square root of 16 times square root of 2, because 16 times 2 is 32. So that's going to be 4 root 2. So square root of 32 is 4 root 2. Well, I have like terms again because they both have that root 2, so I can add the 7 and the 4 together. All right, we are at 24 minutes, and the notes video was really long too, so I think I'm going to try to speed this up a little bit. I'm going to give you the answers, and then you can try to work through them if you want. The answer to this one is, if you don't understand it, you might try to work through it, or you can text me if you have questions. That one's 15 root 3. This one right here is going to be, I'm going to write at the bottom, 3 root 3. This one is negative 3 root 11. And if you just write the answers, I'm not going to count off, but you need to make sure you understand this. Okay, so this one's a little bit harder. Let me work through this one. This one is root 9 times root 3 times root x squared plus this is root 3 times root x to the 4th. Okay, so I have 3x, because I'm taking out the 3 from there and the x from there, root 3, plus, and then I have 3x squared. I can't simplify that. Oh, I'm sorry, root 3 times x squared. Sorry, that can't be simplified. Okay, so I'm going to rewrite this part. 3x root 3 plus x squared root 3. I can add these, I can kind of combine them, but x squared and 3x are not what we call like terms. So the way I'm going to have to rewrite this is, actually I'm just going to leave it like this. That might be the easiest thing to do. X squared root 3 plus 3x root 3. So I think I'll just leave it like that. That'd probably be the easiest thing to do. I mean, there's another way I could write it. I could write root 3 times x squared plus 3x. I don't know if that's much simpler though. Either one of those would be right. All right, so we're at 27 minutes. That was a long time. I apologize, but wanted to get all that instruction in as well, because I think the lesson was good, but I couldn't explain everything fully like I wanted to. So just a reminder that you do have a test this Friday, and it is going to cover this week's work and last week's work, but I will give you a really good test review on Thursday so that you will be prepared for the test.